Okay, so in this particular screencast, we're going to check to see if we can figure out some of the relationships in the shapes of electric fields and what the pictures can tell us. Okay, so in this one, we are trying to figure out, number one, which of these are incorrect. Now, again, it's always out of the positive, so the arrow should come out of the positive and into the negative. So this is fine, and this is fine. Now, that's not correct because it's going into the positive, and that's not correct because it's coming out of the negative. Okay, now, this one here is also not correct, and the reason is you have a circle for 2 dimensions, a sphere for 3 dimensions. The field should be symmetrical, so it should come out equally spaced all around. You shouldn't have a bunch of extra lines on one side than the other. Okay, when you have our friend Aaron again, you know that somebody is going to be wrong about something. And the problem here is these two spots. The electric field lines cannot cross. They are the addition of vectors, so they can't cross over each other. In this one, first of all, I can tell they're opposites because this is an attractive field here. The one is being attracted to the other. And then it goes into the left and out of the right. So that's negative on the left, positive on the right. Now, when you're looking for relative field strength in a space that you have, so we have this electric field space here, you want to look for places where the field is close together for a high electric field strength. So when they're close, the electric field strength will be large. And then when they are far apart, the electric field strength will be small. So we're going to try to rank these in order of smallest to largest. So see how D is kind of isolated out here? It's not very close to anything, so it's definitely going to be the smallest. Now the next one, the spacing between here and the spacing between here and here looks a little larger, a little further away for A, so I would pick A as my next one, and then E for my next one. Now C and B from the picture are kind of hard to tell. I mean, that's pretty close together right there, and it's pretty close together right there. I would take B next and then C, just from what I see from the picture. But these two are very darn close. I wouldn't be too worried about picking one or the other. Okay, from the picture that we have. Again, spacing between the lines. Okay, 5, we're looking at being able to identify positive or negative. It's pretty straightforward. If the arrow comes out, it's going to be positive. If the arrow goes in, it's going to be negative. So arrows out, plus. Arrows in, negative. Arrows out, positive. Arrows in, negative. Arrows in, negative. Arrows out, positive. Arrows out, positive. Arrows out, positive. Arrows out, positive. That's all there is to it. Again, it's always the direction that a positive test charge would go. And it's going to be repelled out away from positive charges, and it's going to be attracted into negative charges. Okay, now this one we're looking at comparing the relative strength just of the charge on each object. And again, now you just want to look for the number of lines or the amount of lines in a space, so the line density. Okay, this one, if you count the number of lines, there's a lot less here, about twice or half as much. So that indicates that A is stronger, so A is greater than B. Here, same kind of thing, you got a lot less lines coming into C than are coming out of D. So that indicates D is stronger than C. And this next one, you can see this is a good one where density really helps. See how close these lines are together? It's got the biggest density for sure, so F is going to be the greatest. And then over here, see how far apart these are? There's only 4 lines, and over here there's at least twice as many as that. So that means E would be larger than G. This one again, density is going to be your best bet. The density around I is extremely large. Everything's packed in tight. Lots of field lines per small space. So it looks like I is going to be the biggest. And then if you compare H and J, there's a lot of space getting out here. The density is not that great out here. This density looks definitely larger than the density for J. You can try to count those lines. It's a little hard to count the lines just because how tightly packed they are. But I would definitely say that H and J are I'm pretty confident that H would be larger than J in this case. So those are some of the things you can tell pretty quickly from the different patterns. You can tell which charges are positive and negative. You can tell which charges are stronger than others. You can tell where the field is strongest and where it's weakest. And that's it for this idea.